Question number 1 is a simple statement of the term relative isotopic mass. Now this is knowledge, you need to learn these off by heart, and it is the mass of an isotope compared to the mass of 1/12 of the mass of an atom of carbon-12. All of that is needed for the mark. Sometimes this is 2 marks and sometimes it's 3. Question number 2 is a straightforward calculation of protons and neutrons using 2 different isotopes of iodine, iodine 127 and 131. The number of protons we get from the periodic table, and this student has got it correct at 53. The number of neutrons is 74. We get this by looking at the mass number, which is 127 or 131 for the 2 different iodines, taking away the number of protons, which is the bottom number, and coming out with 74 for iodine 127 and 78 for iodine 131. Part B is a calculation asking us about iodide ions and Ki. We also have to bear in mind that we have a conversion factor here from micrograms into grams. So calculate the mass of Ki in micrograms that would be needed to supply the GDA of iodide ions and give your answer to 3 significant figures. Now my working over here shows the first stage in this would be to calculate the number of moles of iodide ions. 70 times 10 to the minus 6 divided through by 126.9, which gives us an answer of 5.52 times 10 to the minus 7. 126.9 is the molar mass of an iodide ion, which is the same as an iodine atom because it has 1 extra electron and the mass of electrons is negligible. And the mass of iodine is 70 times 10 to the minus 6, and we know that because we extracted that information from the question. We then have the Ki. And if we look at Ki and we take 5.52 times 10 to the minus 7 and multiply it through by 166, this will give us the mass. So we're taking the number of moles of Ki, which is equal to the number of moles of iodide ions, because the stoichiometry is 1 to 1. We're multiplying by 166 because this is the molar mass of Ki. And you can see that in addition to that, I've divided through by 10 to the minus 6. This is because the question states that it would like our answer in micrograms, and also to 3 significant figures. So if we look back here, it gives us a conversion factor to convert micrograms into grams, 1 times 10 to the minus 6, and I've just used this value to do that conversion. We know that it's 3 significant figures because it tells us here in bold, and we know it's micrograms because if we look at the answer, the unit is included there for us. The next question, apart from costs, why do some countries not add Ki to the table salts? Now this comes into 2 different sections, either ethical or dietary. Ethical, it's just wrong to add something to someone's food, or dietary, we already have enough iodide ions in our diet and therefore we wouldn't want to add any additional ones. For C, write the ionic equation for this reaction. We're looking at a reaction with potassium iodide and chlorine gas. This is group 7. And we know that group 7, when they are bonded to group 1 metals, undergo displacement reactions. So the ionic equation for this student has almost got it right, would be indicated here. Cl2, the chlorine gas, plus the iodide ions, which are not bonded to each other, so 2 at the front rather than at the bottom, which turns into 2 chloride ions, which are released up to bond to the potassium, and iodine, which is released. So this is an example of a displacement reaction. Next question for question 1 is asking us to look for 6 marks at the bonding. Bonding questions are all very, very similar. Here it's asking, explain in terms of intermolecular forces present why ICl has a higher boiling point than Cl2. I've summarised it very briefly here. ICl has a permanent dipole. We know that it has a permanent dipole because we have 2 substances that are bonded together that have differences in electronegativities. Chlorine, 2 chlorines bonded together, they do not have any difference in electronegativities, and therefore they only have London forces. We know that the permanent dipole is a strong intermolecular force, and London forces are weaker intermolecular forces. So the permanent dipole is stronger, and therefore more energy is required to separate the chlorine molecules from each other as opposed to the iodine and the chlorine.